The string, we're using money to understand these fraction sums. And in this one, things are going to get a little bit tougher because we have less landmark fractions to deal with. So for example, we're not going to just have fourths and halves and so forth to deal with, like 25 cents and those connections. But we have to actually use those to understand these fractions here, and then we're going to deal with some less friendly fractions like 40ths and 50ths as well. So we encounter a 50th right here in the beginning. But let's talk about 1/100th first. As a coin, that needs to be 1 penny. So 1 cent, 1 penny. The question then is, what's 1/50th? Well, in other words, what goes into a dollar 50 times? And that's 2 pennies, or 2 cents. And altogether we have 3 cents, or we can think of that as 0.03, 3 cents, which equals 3 out of 100. But again, this is a string, so we're not just concerned with the answers, but the patterns and connections. What do we do here? Well, we took 100, right? And then we divided that by 2, and we get 50. So 50 is a half of 100. But the 1 up here stayed the same. So what happened to our value? If we took 1/100th, and then think about that to understand 1/50th, we halved 100, and what happened was we got 2 pennies instead of 1. In other words, when we halved 100, when we divided it by 2, we made our fraction twice as big. Right? We made our amount twice as big, and that's an important thing to start thinking about in the string. When we take our denominator, divide it by 2, if our numerator is unchanged, it's still 1 and 1, then our value doubles. So having the denominator doubles the value. That's going to help us here. So now we have 3/50ths. Well, 3/50ths is going to be 3 of these, of 1/50ths. And that's going to be 6 cents, right? We have 3 groups of 2. And 3/100ths is like having 3 pennies, or 3 cents. And that's like having 9 cents. As a fraction, that's 0.09, or 9 out of 100, 9 cents. Okay, so look at this. I mean, we have some connections right here. Instead of 3/50ths, we have 3/5ths. So instead of 50, we have 5. Instead of 3/100ths, we have 3/10ths. So we talked about this before as tenths being dimes. So every tenth is 10 cents. So 3 of them will give us 30 cents. And fifths we talked about as being 20 cents. So 3 groups of fifths is like 60 cents. And this gives us 90 cents, or 0.9, or 90 out of 100, which is like 9/10ths. So let's talk about some connections here. Notice this is a string, so we want to look for any kind of pattern we can find. So first we had 3 cents, then we have 9. So this is 3 times bigger than this former one. And that makes sense, doesn't it? This 9 cents is 3 times bigger than 3 cents because each of these fractions were 3 times bigger than the fractions here. Instead of 1/50th, we have 3/50ths. Instead of 1/100th, we have 3/100ths. And now, this is 10 times bigger than 9. So 9 times 10 gives me 90 cents. And that makes sense too because 3/5ths is 10 times bigger than 3/50ths. And 3/10ths is 10 times bigger than 3/100ths. And that makes sense because, well, I guess one way to explain it is look at these denominators. 50 to 5 and 100 to 10. These denominators were divided by 10. 50 divided by 10 is 5, and 100 divided by 10 is 10. And when we divide our denominator by a number, the fraction becomes that many times larger. Remember in the first one, where we did not change the numerator, we divided by 2 from 100 to 50, and our answer, this value, this fraction, was twice as large as this one. Now when we divide our denominators only by 10, we don't touch the numerators, our answer becomes 10 times bigger. 60 is 10 times bigger than 6. So 3/5ths is 10 times bigger than 3/50ths. 30 is 10 times bigger than 3. Just like 3/10ths, 3 dimes is 10 times bigger. Sorry. than 3/100ths. And in explaining all this, I hope I'm not talking in circles here and confusing you, but you want to look for connections here. And this is going to carry us right into these tougher problems below. So now we have 3/4 and 3/5. Well, we knew that 1/4 is a quarter, so 3/4 is just like having 3/4, or 75 cents. Or we can write just 75. In fact, I will write that. So 3/4 is 3/4 of a dollar, or 3/4. That's 75 cents plus 3/5, which we said here is 60 cents. So 75 and 60 is like 135, or $1.35, which I can write as 1 and 35 out of 100. Alright, we keep going now. Now we get to the 40ths and 50ths. And at first that might seem intimidating, but let's look at these connections here. 3/5 to 3/50ths. 50 is what? Well, that's 10 times bigger than 5. So instead of 3/5, we have 3/50ths. Really tiny. They should be 10 times smaller than 3/5. So instead of 60, we get 6. And if we go back earlier in the string, we can check that reasoning. Remember, 1/50th was 2 cents. So 3/50ths should be 3 groups of 2 cents, or 6 cents. 3/40ths, what's that going to be? Well, if 3/4 is 75 cents, 3/40ths, 10 times smaller, because our denominator is 40 instead of 4, it's going to be 7.5 cents, which is weird because now we're getting a fraction of a cent. And 7, I know that's right, because 7.5 cents, if I had 10 of those, I would have 75 cents, right? So here altogether we have 13.5 cents. And look at this connection. This is why I love strings, so you can keep connecting these numbers to check your reasoning. 3/4 and 3/5 gave us $1.35. So now we have two groups of fractions that are 10 times smaller than their respective fractions before. So like 3/50ths is 10 times smaller than 3/5, and 3/40ths is 10 times smaller than 3/4. So overall, our answer should just be 10 times smaller. So instead of $1.35, we get 13.5 cents, which, look at me, I'm writing this incorrectly. 13.5 cents. I should write 13.5 cents. Or, to keep it in the same format as here, 0.135, right, dollars. If you take 13.5 cents and you have 10 groups of them, you will get $1.35. This is dollars here. And last, we have 3 3/40ths plus 4/40ths. Well, we knew what 3/40ths was, right? That was 7.5 cents. So we have that right here. So we have 3 3/40ths. So it's $3 and 7.5 cents. So I want to write that like this. 0.0, here's 7 cents. And a half cent would go there. So I think that's helpful to think about it like that. Plus 4/40ths. And now things get a little bit tougher, but we can handle it. What is 4/40ths? Well, there's a couple of ways to think about this, and I guess one thing that would help me is to try and reduce this. If I have 4/40ths, if I divide 4 by 4, I get 1, and 40 by 4, I get 10. So 4/40ths is like 1/10. And again, I just knew that because I reduced the fraction. I can think of 4 divided by 4 to get 1, and 40 divided by 4 to get 10. That's like having a dime, 1/10. So that's like $0.1. So altogether we get $3, here's 10 cents, and then 0.75 cents, so it's like having 17.5 cents. That's a tough one. But another way to think about this, to use the string even more, 4/40ths. Well, we knew what 1/4 is, right? 1/4, because I'm trying to figure out, sorry, what is 1/40th? What's the connection between 1/4 and 1/40th? Well, 1/4 is 0.25, right? So 0.25 cents, or 25 cents. In fact, I'll write it like that, 25 cents. So what is 1/40th going to be? Well, 1/40th, 40 is 10 times bigger than 4. So 1/40th is 10 times smaller than 1/4. And that's going to be 2.5 cents. So every 40th is like having 2.5 cents. And 4/40ths is then 4 groups of 2.5 cents. And I would have, well, 4 groups of 2 cents is 8 cents. And we're splitting this up, distributive property. And then 4 groups of half cents is 2 cents. That's like 10 cents. That goes back to the reasoning here. So, I don't know, I think that I might be talking terribly about this and confusing you, but we can use this idea of the string to figure out what even a nasty fraction like 4/40ths is, or we can reduce it to realize, oh, that's just a dime. Alright, hope that helps.